Okay, hello and welcome to this. So this topic is going to be on the solubility of a common ion. And the whole thing here is that in the past, on the problems that we've worked with, we have been taking our solid and dissolving it into water. And therefore, when we did our ice table, our rice table, we would always say that we started with zero products. You started with reactant, but you had no products to start with. Well, the difference here, because of a common ion, instead of putting our solution into water, we're going to put it into a solution that already has one of the ions into it. Therefore, there is already some beginning ions. So let's just jump in and get started. So on this one, here's what we're doing. We're taking an iron hydroxide solution, and we are going to put it, or just some iron hydroxide solid, if you want to think of it, and we're going to put it into a solution that already contains some iron in it. So it's no longer water. So it's not water, okay? So we want to determine the molarity after we've dissolved this iron hydroxide in this iron solution. What's going to be the molarity of it? So steps. Again, the first thing you're always going to do is write that equation. So that's just kind of always going to be our first step. So we have that we have our iron hydroxide solid that we're going to put into it. And it's going to dissociate into the iron, and again, this would be iron 3 because of that 3 there. And then we've got 3 hydroxides on that, and hopefully by now that's a piece of cake for you guys to do. Now, that's the first thing. Now we're wanting to, again, calculate out the molarity of our, what's the molarity of the solution, the ending solution on there. So I'm going to go ahead, since I've got this written, and just do my rice table straight from here on that. So I guess I needed to draw those lines, but oh well. So initially, change and what it would be at equilibrium. So again, remember, this is our solid that we are putting into the iron solution on there, and it is going to, just like before, we are going to lose some of that iron to the iron over here. So that piece doesn't change. What changes is, again, when we usually say, okay, if we have all of this is solid, we have not put it into the solution of water yet, or into water yet, this would be 0. But we're not putting it into water. We are putting it into this iron solution. And so this, in fact, does have some concentration to it. And it is 6.5 times 10 to the 5th. Now, there's no hydroxide. It doesn't say anything about hydroxide. So that one is 0. So when we go to do our equilibrium, we now have 6.5 times 10 to the negative 5 plus x and 3x. Okay? So there is our box. So that's the only thing we're going to add, guys, to these problems, is look to see what they put it into. And if this has one of these ions, then we have got to include that molarity here in our problem, which is going to make the problem a little bit more difficult when we actually go do it. So let's go ahead then and set up our equilibrium expression. So we want our KSP, and we're going to have our iron, and we have our hydroxide, and that's cubed. And then, let's see, what else does it give us? It gives us data. And it's kind of hard to see there, but there is some data here. It tells us that our KSP is 1.6 times 10 to the negative 39. So that would have to be given. And again, we're assuming that is at 25 degrees Celsius, even though it's not stated. Okay. And again, our iron, okay, and our hydroxide and cubed. Okay, now when you look at this, we've got some pretty nasty numbers, if you want to think of it, to work with here. Especially, you know, this 10 to the negative 39, we've got 10 to the negative 5, and so forth. And so I think I put it on here somewhere. I want you to take a look in your packet, and at the very bottom, it's actually on your answer sheet. So take a look on your answer sheet. And chemistry, as one of the people said, chemistry, you know, is not about math. We do a lot of math, but we're not trying to teach you how to do math in here. And so if we can simplify it, we're going to do that. So in chemistry, there's what they call a 5% rule, okay? And it is a tool used for simplifying calculations, specifically the equilibrium problems, when we get those kind of equations that we just did. We're also going to use it in the next chapter when we're doing acids and bases. So realize that if you get something that is just horrible, there's probably a way in here that you can simplify it down, okay? And so what we're going to assume on that is that if your number that you're working with is very, very, very small, so small that it's not going to make any kind of a difference to it, we say that they kind of do what they call an approximation answer. And so typically that 5% rule is going to apply anytime your KSP value is less than 10 to the negative 5. So that's kind of our break point, 10 to the negative 5. They do say 10 to the negative 4 might work, but it might not work. And so KSP less than, if you just use that rule, it's called the 5% rule, then you should be okay. So let's go back to our problem. And in our problem, look at our KSP. It is very, very small compared to that 10 to the negative 5. Okay? So definitely we can use the approximation. So what we're going to do here is we're going to use the 5% rule. And what that allows you to do is it's saying that basically this X value that you are computing is so small to get this to be this over here that we could ignore it. Okay? And so what we're actually going to do is ignore the X here. Okay? So again, that does not change our answer much if we add or subtract that X because it's so small. So I'm just going to rewrite this without the X. Now, not this X, we're going to keep it. It's just that one that we add or subtract, because when we add it or subtract it, it's so small again, it doesn't make a difference. So we're going to still hang on to this one. So it's always going to be the one that you add or subtract. Okay? You can't eliminate both of them, obviously, because then you wouldn't have an equation. And then you're just going to run that in your calculator. So let's run this in our calculator and see what we get. Now, let me back up, because one thing you might want to do, back up before I have you put it in your calculator, is it might be easier to move this over first so that you get all of your exponents and so forth together here. And what that'll leave you on this side is your 3 cubed, which is 27x cubed. Okay? Now, do you have to do that? No, you don't. You could have distributed this and then divided it over. But typically it's easier to go ahead and move this piece over, run that whole thing in your calculator, and then solve it from there. Okay? So go ahead and put that all in your calculator, and again, make sure you can do it correctly, and then I will tell you here what the answer is. And so it should give you 9.7 times 10 to the negative 13. Okay? And again, you can go back in and check and see if this in fact is less than 5%. Okay? And if we need to, we can talk about doing a check just to see. Oops, I didn't sorry, let me put that in there right. Your final answer is 9.7 times 10 to the negative 13. Okay? My bad. Okay, hopefully you had that and realized that I put that in the wrong spot. Okay, does that make sense? So again, the only thing that we're adding in is this little piece right here and the 5% rule that allows you to eliminate that x there. Okay?